All right, so today we're in for a treat. We have Nestor Maslej. He is a research manager at Stanford's Institute for Human-Centered Artificial Intelligence. And more importantly for this episode, he is editor-in-chief of the 2024 Artificial Intelligence Index report, which I try to feature every year when it comes out on this podcast. So Nestor, welcome to the Data Exchange podcast.
Very happy to be here. Thank you for having me.
So, I guess I never asked this from my previous guests when the report was released, but just to clarify, so is the report uh officially an HAI document, or is it a collaboration between multiple organizations? So who's the official publisher of the report?
Yeah, so it is an HAI document, but it's definitely a collaboration. The AI Index was created about 7 years ago by kind of a diverse steering committee of influential AI thought leaders. And since then, it's kind of migrated full-time to Stanford High. But the way that the report is put together is myself and my research associate, Laura Donna, we work to think of different topics, think of different areas of interest that we feel are important for looking at in the AI world. And then we dialogue with our steering committee, which is around 10 people. It includes certain individuals like Jack Clark, co-founder of Anthropic, Eric Brynjolfsson, who's a really influential AI economist, and people like James Manika, who's an SVP at Google. So we work with them to ascertain what kind of topics we think are the most important to cover, and then we work to feature those in the report. So it's definitely quite a collaborative endeavor, I would say.
All right, so for our listeners, so there's no substitute to actually downloading the report and getting yourself a copy, because there's no way Nestor and I can cover this entire report in this podcast, even if we spend 3 hours.
Yeah, we'll try our best, but yeah, it's definitely pretty thick.
It's a long report, yeah. So we'll cover a few chapters that I'm particularly interested in. So starting with chapter 2, which is on technical performance. Um, So I guess the first question here, Nestor, so this is a chapter um, which basically includes a lot of benchmark kind of
Yeah.
results, right? So for our listeners who are more on the developer side, industry people who don't follow benchmarks, uh, what's your kind of guidance to people when they come across a release and then they say, "Hey, here's our new release. It beats this benchmark." So how would someone who's not deep into the weeds of benchmarks interpret benchmarks?
Well, I mean, I think it kind of points to a broader thing that this most recent AI index has made clear is that the world of benchmarking in AI has certainly changed. And I mean, I think that when you look at a lot of these canonical benchmarks like ImageNet being one of the kind of founding original benchmarks in the AI space, I think we've kind of continued benchmarking a lot of these AI systems against these very academic tests. But I think one of the things this year's AI index report reveals is that it's not necessarily clear if moving forward that is the best way, or perhaps, we might need to broaden our horizons. And what I mean by that is like, on a lot of these classical benchmarks, AI already exceeds human capabilities. So that's one of the things we talk about in the report, that whether it's visual reasoning, whether it's image classification, whether it's English language understanding, AI has exceeded human baseline and human capabilities. And it's even the case that on some of these newer, more challenging benchmarks like math, which is a benchmark for competition level mathematics, AI is getting very close to the level of three-time gold medalists at international math Olympiads, and it's doing so very quickly. So the world of benchmarking is moving fast and it's changing. But what I mean when I say that it might be worthwhile to think about different modalities and different approaches when it comes to benchmarking is that we're now in a world where AI is becoming increasingly industrialized. It's being used by many people in the real world. And some of these benchmarks are testing, for example, whether AI can solve, grade school math problems. But if you're a business, you're probably not solving grade school math problems for your business. And I think it kind of points to the fact that human evaluation also really appears to be in this year. One of the trends that we find in the index is that it's increasingly the case that a lot of these new AI systems are not only benchmarked on these very computer science-based tests, but also measures of human evaluation. Which tools do actual humans prefer? And that's a very interesting change that we seem to be seeing in the landscape.
And actually, so for me personally, and I think for many of our listeners, my approach to benchmarks is I look at them and they serve as kind of more like a initial filter of some
Yeah,
kind, right? So, and then there's no substitute to trying it out yourself
for
and
sure. I mean,
trying it out
especially
on your use case and your data,
yeah,
right? So, yeah.
especially in this kind of age of generative AI. I mean, let me tell you a story. I think that, zooming out, it's good to look at the benchmarks because they can tell you like this is how much better AI has gotten at some of these tasks. You can see the pace of improvement. You can kind of know where these systems are. But one of the things that we did do for this year's report is we used AI as part of the writing process. More specifically, we would use tools like GPT-4 and Claude as copy editing assistants. So we would write our own text and then we would feed it to these tools and see it if it could copy edit the text and tighten it. And it was really funny. I mean, Claude and GPT-4 are completely different copy editors. And it's unclear to me which one I prefer at this moment, but it's really clear to me that these models behave in different ways. And depending on what kind of output you want and what result you want, it really is worthwhile to test these models and to use them. But to my knowledge, and I say this as someone who spends his day job actually tracking a lot of these benchmarks, there's not a lot of benchmarks for industrial AI use cases, right? Like the way in which businesses might be using AI is a lot different than the way in which these models are tested on. And I think that speaks to a real kind of market opportunity or kind of something that needs to be solved by someone in the near future.
So now you did mention that the AI systems, at least on many of these benchmarks, has for a few years now been beating humans. But there are still some benchmarks where these AI systems are not beating humans, and they tend to be on more complex tasks. So can you give us kind of a high-level overview of the types of benchmarks where humans still win?
Yeah, so I mean, I think it tends to be benchmarks that are a lot more kind of complex from a reasoning perspective. So one of the ones is math, which is a benchmark of competition level math problems. And I mean, the current state of the art AI systems are pretty good, and they're just behind the level of someone who would be like a three-time Olympic international math Olympiad medalist. So that's one area where AI still kind of trails state-of-the-art human capabilities. There are other benchmarks as well, like visual common sense reasoning, which require AI systems to interpret images and videos and kind of make common sense inferences, like why is this person paying that other person? Why did this person laugh in this kind of context? And there's also evidence that on some certain kinds of tasks, like planning, a lot of these AI systems still really struggle and still fail to get to the human level. So I think it's kind of on a lot of these more difficult knowledge task categories that these AI systems are still kind of a little bit behind humans. But I mean, we shouldn't kind of discredit these AI systems and the tremendous progress that has been made with them in the last few years. I think one of the things that kind of excites me the most is if you look at the AI space and you zoom out, I think historically, even 5 years ago, 4 years ago, you had AI models that could do certain narrow intellectual tasks very well, like, read text or classify images. But to me, what really kind of defines human intelligence is flexibility, right? Humans have the ability to read, they have the ability to speak, they can listen, they can, move kinetically. I think historically it was difficult to develop AI systems that had that kind of multimodality, but we're increasingly starting to see a lot of these large language models like GPT-4, Claude 3, and Gemini that can write text, they can handle images, and they can even explain jokes to you. And I think that represents a real interesting kind of frontier in the future of AI.
So I can personally attest, actually. So I'm quite impressed with Gemini 1.5. And not only is the API fast, it's simple, but also multimodal. So if listeners haven't tried Gemini 1.5, I think you should go check it out. It's unlike Google's previous releases where you had to go jump through many hoops, get a Google Cloud account. No, now it's just simple. Uh, get an API key and you're good to go. They really lowered the friction in terms of trying it out. So multimodality, um, there must be benchmarks, right?
I mean, there are, but
What did the benchmarks say in terms of these
I mean,
multimodal systems? Yeah.
I mean, that's another thing. It's like, I think one of the big questions now is AI has become a lot better. And I think now in the AI community, you often hear this kind of question or refrain, when are we going to get AGI? I mean, I think to me that's an interesting question, but the first one is, what do we mean by AGI? Because I think everybody has different definitions for what that actually entails. And I mean, there are new different benchmarks that have emerged. So for example, one of the ones that came out, or two of the ones that came out in the last year were GPQA, which was a graduate level benchmark of kind of question and answer type modalities. And then MMMU, which was a set of kind of difficult college level multidiscipline questions. Now, these were a little bit more multimodal in that you required knowledge across a variety of subjects. And it seems like AI systems still kind of lagged behind humans on these benchmarks. But I think what we're kind of talking about is like a test for like, living in the life of a human, which is like, cooking an egg one moment and then perhaps reading a book another. And, to my knowledge, there isn't really like a comprehensive benchmark suite that the AI community as a whole has embraced for these kinds of challenges. But it kind of also speaks to the pace at which the field is developing, right? I think a decade ago, a benchmark like ImageNet would serve the community for 5 years. It would be something that researchers would use again and again. Whereas now it seems like you introduce a benchmark and within 2 years, the best AI model has topped it. So these systems are getting better, but there's also an opportunity to create new methods and ways to actually test some of these systems.
Fun fact for our listeners regarding these benchmarks that Nestor has alluded to. If you actually carefully at what these benchmarks are, they are hard, man. Like
Yeah.
he mentioned Math Olympiad questions. They're not trivial. They're not trivial
Yeah,
questions.
yeah.
Now, on the other hand, they're not exactly the types of questions that, as Nestor alluded to, businesses might be concerned with, right? So,
Yeah.
Nestor, do you know, is there a concerted effort among researchers? Is there a sub community among researchers focused on improving benchmarks?
Yeah, there definitely are. I mean, there's a lot of researchers that kind of make it their mission to think of new benchmarking suites. I mean, I know at Stanford, you've had benchmarks that have come out like Helm and Heim, which have looked at kind of creating these general benchmarking suites for large language models and also text to image models. And yeah, there's definitely a lot of researchers that do think kind of critically about that. But I mean, also the kind of the name of the game has changed in the AI ecosystem. As I kind of alluded to, I think 5 years ago, 10 years ago, AI was very much an academic problem, as in, it was something that university researchers were working on. Whereas now there's big money involved, there's industrial applications, businesses are using it more than ever before. And as I alluded to earlier on the podcast, there are different things that now matter. There are different considerations that become increasingly important. It's not just a matter of kind of knowing what can these systems do academically, but how do they operate in business settings? And businesses have different needs and utilities when it comes to kind of deploying AI.
So actually, it's interesting because for LLMs, right? So the main leaderboard that I push people towards is LMSys,
Yeah.
which is out of UC Berkeley, which it's an interesting leaderboard in the sense that it actually uh, combines kind of the human evaluation, right? So
Well, yeah, I think,
it
yeah,
seems
this
like
was
that's
one.
an important ingredient for these benchmarks, right?
Yeah, I mean, this was one of the ones we featured in the report this year. But yeah, I think it kind of speaks to the fact that yeah, human evaluation is very much in, right? These are now tools that are being used by humans, and how humans rate these tools and think about these tools really kind of matters a lot. And I don't want to say it's easy for a company to top a benchmark, but if you're Anthropic, OpenAI, or Google, you could top a certain benchmark and say like, oh, my system is, the best on GSM 8K. But does that really mean that users prefer to use your system versus another? So the question of how humans feel is going to become increasingly important and increasingly salient when actually evaluating which systems we prefer and thinking about some of the other elements that come with these systems as well.
So it seems like the rite of passage for releasing a new model is you have to tell us what you did in all these standard
Yeah.
benchmarks, right? So now what you're alluding to is maybe besides that, you have to tell us something more, right? So
Yeah, I mean, I think it would be interesting, and I think it kind of speaks to the direction the community is moving in. But I mean, even if you read a lot of these research papers, one of the things we did in this year's report is we really started to profile much more individual, in-depth research in the technical performance chapter, research that we thought was really meaningful and really significant for some kind of reason. And if you look at a lot of these generative models, yeah, they weren't only benchmarked on computer capabilities, but very often it was like we would evaluate our model versus five other models with a suite of human evaluators. And this is by how much a team of human evaluators appreciated our model. And it really kind of goes to show you that that is becoming an increasing concern for researchers and people that are developing these models.
so very I guess quickly before we move on to the next chapter, so a lot of people obviously are focused on LLMs and text, but
Yeah,
what are some highlights from your perspective for this year in computer vision and speech?
that's a
What are some really interesting things that are below the radar?
yeah, that's a really good point. I think it's not just computer vision and speech, but I'll touch on a couple of different things. I think one thing that you're seeing the kind of architecture style that is being used to power a lot of these large language models. And by that, I mean kind of transformers that tokenize context that is coming in. People are starting to use these kind of architectures in non-linguistic domains. So for example, for creating, higher quality image generators, for creating higher quality speech generators. And that's something that I think is really exciting to see. And it points in a lot of ways to how the AI research community really, really borrows from one another. But for instance, Uni Audio was a high level language modeling technique that was used in the domain of audio. And you have these models now that really can create very high quality audio types, and kind of also you can feed in melodies and use that as a means of kind of doing editing, not just with Uni Audio, but with models like Music Gen and Music LM. And I think you're starting to see a similar thing in computer vision where you have these kinds of architectures also very usefully serving people. There's a couple of other models that I'll kind of highlight in the domain of computer vision that I think are meaningful. One is kind of ControlNet. ControlNet is a new model that came out that made it substantially easier to do conditional control editing for images. That's kind of, when you have like an input poser layer and you want to edit it in particular ways, it's now a lot simpler to kind of use textual inputs to do that. And a lot of these developments, in a lot of ways, really speak to how research problems in the AI community have become much more kind of focused and narrowed. Another really interesting model development, because I think this also kind of speaks to a broader question we can maybe touch on, is segment anything. So this is a model that was released by Meta, and it performed well on a bunch of different segmentation benchmarks, but I think was particularly interesting because it also came with the release of a data set that had, I think, close to 100 billion segmentation masks. And I think it's interesting to see how AI systems are now being used to, I don't want to say create data, but to basically make it easier to extract data from the existing world, which you could imagine being very useful in powering subsequent AI developments. But I think it's also worth chatting about another kind of few areas of developments that I think are really interesting are also in the domain of robotics and agentic AI. I think those are two fields that saw a lot of really
Well,
interesting
yeah,
progress
yeah.
this year as well.
I was going to ask you about agents, right? So in
Yeah.
2022, 23, the word of the year in industry was co-pilots.
Yes, that's
And
right.
now in 2024, we're still early on, but I think the word of the year is agents.
Yeah,
So give us a high-level overview of what's the latest on the research side as far as agents. And I guess, Nestor, for the sake of our listeners, maybe give a kind of a very rudimentary definition of
sure.
agents. Yeah.
Yeah, so I think the kind of textbook definition would be an autonomous or semi-autonomous agent that could, or system that could operate within different environments to accomplish goals. But I think in practical terms, think of something that could book vacations for you, that could do online shopping, like a tool that could, schedule things for you. Like maybe you open up your Outlook one day and you say, I want to do a boxing class at 8 a.m., but one of my clients wants to meet at 9. Can you figure out a way that I could both box today and meet this client? And then the agent kind of does the scheduling for you. And that could obviously be really exciting because you could imagine a lot of productivity gains, not just in work, but kind of around the home if you have these tools that are helpful in these ways. I think what the research is suggesting is that, existing models are somewhat capable, but it still seems they kind of lag behind in terms of creating these systems that are really functional and deployable in the real world. But it does seem like the AI community as a whole is much more interested in this question. One of the things that you saw in 2023 was the release of new benchmarks like Agent Bench, which was a new benchmarking suite for agentic AI. Another one was ML Agent Bench, which was trying to test whether agents could be good computer science research assistants. And they found that on some tests, they could actually be pretty useful, but on other tests, they couldn't really be. And then there was, of course, developments that came in the last year, like Voyager, which is a model that was, I think, based on GPT-4 that was able to play Minecraft at a very high level. Minecraft, of course, is a very complex, open-ended video game. So the fact that you had an AI system that could do well in this environment speaks really well to the kind of developments that are occurring in the space of agentic AI. I mean, it seems to me kind of my take looking at the literature is that we're maybe still not right at a moment where we have like a chat GPT for agents, like a functional agent that could help you do what you need to do. But it wouldn't surprise me if that's around the horizon because the research community really seems to be prioritizing that kind of research. And the pace of AI even surprises someone like myself that kind of works in the space, right? So who knows if there isn't somebody at OpenAI or Anthropic that's cooking up the next new agent that we could all use.
Or it could be, it could just be, plugins, right? So the
Yes, yeah,
equivalent, the equivalent of plugins, and it could well be, and that the way these agents would emerge in industry would be uh, in internal focus applications, right? So be more conservative, do these agents for internal facing applications, uh, get your pipelines and your systems in place, get your QA processes in place, really iron out the kinks, and then maybe consider building agents that are much more outward facing. But I
yeah,
think with many of these things, it's, start slow,
yeah,
start
of course.
focused, and then learn, right?
It's also tough with agents because I think that, there are benchmarks for agents, but like agentic AI, that's in a lot of ways, it's a very kind of unique and idiosyncratic challenge, as in, the agent that one business needs is probably radically different than that another business needs. And I think you would want systems that are very customizable and can kind of uniquely be deployed in different business settings and contexts.
So as far as LLMs, right? So it's no surprise that closed LLMs, especially the ones
Yeah,
by the large players, continue to seem to be better than the open LLMs. Now, couple of observations. One, I mean, I think myself and most people still use the closed LLMs as a way to kind of just test things out.
yeah,
And then essentially, Nestor, if you can't do it with one of these leading
yeah,
edge closed
exactly. Yeah,
LLMs,
yeah,
it's unlikely you'll be able to do it with an
yeah,
open LLM unless you have enough fine-tuning data for a very narrow task. And
yeah,
I think I've had a lot of success with fine-tuning for very narrow tasks, especially Llama 70 billion.
yeah.
But what's your sense and as far as open versus closed LLM? So I mean, I think it's likely that the closed LLMs that are backed by well-resourced companies will continue to probably at least for general purpose scenarios, outperform the open LLMs, right?
Yeah, I think that's fair to say. I mean, the index is kind of commenting on the trends we see, and we can only kind of extrapolate from those. I would say two things. I think, yeah, it seems to me that closed LLMs are probably going to lead, at least in terms of the frontier. But I do think at the same time, the open source research community is becoming increasingly vibrant, and I can kind of touch on that a little bit more. But yeah, I mean, when you think about it, I think it's just really a matter of coincidence in that a lot of, well, coincidence is not the right word, but these, the major LLM developers are most of them are closed. And it makes sense intuitively, right? Like, AI is now a billion-dollar industry. And I think there's an understanding among a lot of these developers that if you release the next GPT-5 and you open source it, you're just kind of, maybe releasing the secret sauce that can kind of empower your competitor. And I mean, I think this is sometimes to me like a shocking thought that I have. But if you think about the original Transformer paper, that paper has, basically set off a craze in terms of the whole AI ecosystem. And it was, of course, kind of, released in that kind of relatively open source way, which you cannot imagine a company like Google, Anthropic, or OpenAI maybe doing that today because that obviously is empowering a lot of their competition. So I think because it takes a lot of money to build these systems, and inherently it's the case that industry actors are best positioned to actually be building these kinds of systems, and they have incentives to be closed, you're probably going to be seeing a lot more kind of real frontier research come out of that end. But I do think it's important to acknowledge that the open community is vibrant. There are some really strong players in the space. I think there's data in the index in the first chapter for research development, which suggests that there's more open source foundation models than ever before. There's more open source projects on GitHub than ever before. And yeah, it might be the case that the best models are closed, but even if in 2 years, the best models take, a step forward that's maybe 2x or 3x, you could imagine that open source is also going to take a similar step forward. And maybe in a year or two, we're going to have open source models that are as good as the best closed models today. So I think it's kind of the ecosystem moves collectively. And yeah, although closed is perhaps a bit in the lead at the moment, we shouldn't kind of disparage the tremendous work that is coming out of the open community as well.
So let me push back on a couple of things.
Yeah.
So the first, the phrase open source, I
Hmm.
think open is probably more accurate than open source,
Yes.
right? Yeah.
Yeah. Yeah. That's what we
And
mean
then
here. Yeah.
secondly, Nestor, the number of suppliers worries me, right? Because
Yeah.
basically, if you look at the open models that are decent, what are we talking about here? Meta,
Yeah.
Mistral,
Mistral, probably. Yeah.
Mistral now, the large
Yeah.
model is no longer open.
Yeah. Oh, yeah. That's right. Yeah.
Right? So, uh, yeah. So then DBRX, right? So I don't know. It's too early. Uh, Snowflake supposedly is training a model, right? So, um, but it's basically comes down to Meta, and Meta has a specific license, right? So,
Yeah.
so let's say you can't use Meta for the application you have in mind based on their
Yeah.
license, right? So, so it is still the case. Now, on the other hand, I'm not too worried about the closed models being better in a general purpose sense,
Hmm.
right? So if I know I'm close enough on the open model so that I can fine tune for my task, I don't care. You guys can
Yeah. Yeah.
always wear the crown of being better,
Yeah.
right? But what worries me more, Nestor, is the number of suppliers,
Yeah.
right? So do you have any positive news for us on the number of suppliers of decent open models?
Yeah, that's something that we haven't necessarily been tracking super directly in this year's index, but it was something actually I was talking recently with some of the index team that we're thinking kind of incorporating recently, which is kind of looking at the dynamics of this ecosystem, right? Because as you kind of allude to, it's not just a question of, yeah, how many we have, but also are there kind of super high quality ones? So it's hard to say now. I mean, I think that the jury is still out, and I think the industry definitely kind of moves in very sometimes weird and surprising ways. I mean, you would think rationally that from a competitive perspective, closed is going to be the trend that we're going to see more the future, but we're going to have to kind of wait before we kind of make any proclamations. So maybe if I'm fortunate enough to make it onto this podcast next year when the 2025 AI index comes out, we can have some more hardcore data on that question.
One source of open model supply, in my mind, because they're well positioned to do it, might be the hardware makers, right? So NVIDIA,
Yeah,
AMD, Intel, but
yeah.
I don't think they're necessarily focused on that per se, right? So,
Yeah, I mean, I think what also is important to kind of acknowledge is that, I'm kind of in the business of tracking the AI ecosystem and it moves so quickly, right? So
mm.
it's not like there are some other kind of spaces in the world where you're measuring things that you can rely on the same measurement standards year over year. And there are certain metrics that we do kind of bring back in the AI index, but because things move so quickly, yeah, you kind of, where you're measuring 1 year or a data source that you're using 1 year might not necessarily be super reliable in future years. What we've been using this year to kind of look at the state of at least open foundation models has been the ecosystems graph from Stanford's CRFM, which I think does a pretty nice job of kind of tracking the state of the foundation model ecosystem. But yeah, I mean, as AI becomes increasingly ubiquitous, figuring out ways to have better data documentation and answering some of these questions is also, incredibly essential and incredibly valuable.
Yeah, and then like I said, having a few reliable, have a little more diversity on the supply of open models.
Yes. Yeah.
Um, you know, y- and I guess I can pivot to the next chapter, right? So I mentioned one logical possible source of open models might be the hardware maker,
Yeah.
but another possible source would be universities,
Yeah. Exactly.
Stanford and
Yeah.
Berkeley, if someone would fund them.
Yeah.
But then, let's say best case scenario, right? So they get funded, but that might be, model version one, which costs 50 million. But we
Yeah.
know that they need to update that in 6 to 9 months,
Yeah. Yeah.
right? So the question is, what's a sustainable path? And I guess, which brings me to another trend that you guys highlight, which a lot of people have noticed now for many, many years, which is basically essentially the universities are outgunned, right?
Yeah.
Yeah.
Yeah, and I mean that's that. I mean, we could spend an entire podcast talking about that trend alone, but I mean, there's so much to kind of unpack there. I mean, I think, for listeners that might not necessarily be super familiar, I think up until 2014, the majority of the world's kind of frontier AI models were coming from academic institutions. Since then, it's really kind of been industry massively outpacing academic institutions to the point where kind of our analysis suggests that last year in 2023, there was 51 notable machine learning models from industry compared to just 15 from academia. Why is this the case? Well, I mean, these systems are just very expensive to build. And
And hold on there. Listeners, they have a graph of the cost of training the latest foundation models. And this is another reason for you to download the report. Anyway, go ahead, Nestor.
yeah, but I mean, the graph is quite shocking. And this
Yeah.
is something I think we're quite proud of because I mean, I think everybody knows these models are expensive to build, but to actually kind of do the estimates is challenging. And we partnered with Epoch AI this year to kind of refine these estimates. And yeah, you could really see like in 2017, the first transformer is around $1,000. Then a model like Roberta Large is $160,000. And then you fast forward to Gemini Ultra and it's over 100 million. And it's just kind of, quite shocking to see that upward trend. I think for me, again, there's a lot to be said, but I think there's a real interesting question to be asked about what does this mean for universities? And I think on the one hand, it's important to acknowledge that, institutions like Hyatt, Stanford, they've been really adamant and open about the fact that we need to invest increasingly greater amounts of resources into kind of publicly accessible AI tools. So, Stanford High was really pitching the NAIR and a lot of other, nationally accessible AI research resources, which it seems to be like they're starting to get off the ground a little bit, at least if you kind of look at the pace of AI regulation and legislation in the United States. So I think there's one thing to be said about kind of empowering academic actors to have access to some of these kind of, brilliant models. But it's also, there's a quote that I really like from a very kind of distinguished former Stanford computer scientist, John MacArthur, where I think someone asked him once in the 80s, like, when are we going to get AGI that like works like humans? And he said anywhere from 5 to 500 years. And, his kind of point there was that, to build these systems, there have to be kind of computational innovations, right? I think that what you're seeing recently with these kind of Geminis, GPT-4s, and Claude's is, I think, really the power of scale and data. It's not to say that architectures haven't improved. I mean, they definitely have, and there's new methodologies like RLHF that makes models more efficient and more helpful. But there's probably a few more kind of computationally significant innovations to be had that can maybe get us to the next frontier of AI. And who knows where these innovations are going to come out of? Maybe they'll come out of industry, but it could be equally likely that some kind of academic that is just thinking about crazy things might develop one of these innovations. So I still think academia plays a very important role in the ecosystem, but yeah, I mean, these LLMs that are super high powered, they could do a lot of very interesting things. And it's a bit of a shame if academics don't have as much access to them as they would want to, because, yeah, no academic university will pay $100 million to train, Stanford GPT or whatever.
So another reason, if you're in academia, to relocate to the Bay Area, because you can spend a day a week at one of these companies, like
Yes.
many of these professors do. Um, yeah. So in terms of I guess geopolitics, to put it
Yeah.
kind of diplomatically, I mean, you have, this. You highlighted a pattern that we've been seeing, right? So China is filing a lot of patents. I don't know to what extent patents matter
Yeah. A
necessarily.
lot of that, I mean, it's a
Yeah,
signal, but yeah, I
yeah,
think it has to be considered alongside other things for sure.
yeah, yeah. Actually, before we go into geopolitics, one thing that I want to say to kind of reinforce what you just said, which is it's there's no scenario in my mind where Transformers is the last word, right?
Yeah, yeah, yeah,
So
I would
so
agree
there
with that
will
as well.
be
Yeah.
more innovations.
Yeah.
So now, as Nestor alluded to, Transformers, the innovation occurred in the before times when people were much more open. You know, now we're in a different time. If the innovation occurs in one of these big companies, well, now will they publish a paper as detailed as the
Yeah.
Transformers paper? Now, if
Yeah.
it occurs in a university, as Nestor alluded to, yes, for sure, they'll publish
Yeah.
everything, right?
Yeah.
So this is another reason why we need to figure out how the universities can plug into the frontier, right?
Well, it's also like historically a lot of very important developments, like some of the developments that led to the internet, CRISPR, as well as GPS, they came out of university settings where professors were kind of empowered to pursue research that didn't necessarily have clear profit motives. I mean, of course, these industry players are still, doing a lot of research that isn't always about profit. I mean, I think of like DeepMind, publishes a lot of really interesting scientific stuff that we feature in the report as well. But at some point they do have to make money, right? And that definitely kind of skews the incentives of the researchers that are working on some of these projects and tools.
Or even if even like you said, even if they dedicate 100 people, play like crazy,
Yeah,
try
yeah,
all sorts of
yeah,
architectures.
yeah.
This architecture works great. We'll allude to it. We'll kind of describe it at a high level, but not in a way that people will know exactly how to implement
It
it.
it also speaks
Yeah.
to the fact that I mean these systems like GPT-4, Gemini, Claude, while they're impressive, I mean they've probably seen like a percent of all the data that has ever existed on the internet, or if not more than just a percent. And they see, millions of times more text data than like a 10-year-old sees. But sometimes on certain tasks like planning, children can sometimes, not necessarily make the same mistakes that some of these models do. So I think it's important to acknowledge that the kind of architecture of the human mind is clearly not the same as the architecture of a large language model. And there are probably quite large efficiency gains to be made as well in kind of getting these systems to do a lot more with a lot less. Like the data revolution has been impressive, but I think that's also another role for academics to play to figure out how we can kind of build these really highly functional systems that might not necessarily require, all of the text ever written by humans to kind of be trained on.
So, for about 4 years, I co-chaired an AI conference in China, um, up to I think 2019, so right before the pandemic. Um, so at this point, Nestor, does the title of Kai-Fu Lee's book still hold that we have two AI superpowers, right? So China and the US. Now, granted, there's been an embargo,
Yeah,
and anytime I talk to someone from China, uh, they always complain about hardware, right? So lack
yeah.
of hardware and stuff. So what's takeaway from this year's report about the state of AI in China?
I mean, I think it seems the data would definitely suggest that I think China and the United States are the two biggest players. I mean, and they lead in different domains, but I would say it seems like the United States is maybe a bit further ahead in the aggregate count. This also speaks to the fact that in the summer, the AI index team is going to be launching a new version of a project that we currently have called the Global AI Vibrancy Tool that ranks how well different countries are doing in the AI ecosystem. So, I mean, let's look at certain things that the United States is ahead on. I think more notable models come out of the United States, more foundation models come out of the United States. There is substantially more private investment in AI that comes out of the United States, especially in generative AI. And you can imagine that being quite consequential because there is a lot of interesting innovation activity that happens on the industry side. China, however, is ahead when it comes to the installation of robotics. I think there are more industrial robots installed in China than the rest of the world combined. And China seems to be doing really well on the patent front as well. But again, patenting is not, in and of itself, an incredibly strong solitary signal. There are kind of differential things that you need to consider and weigh there. I think another thing that's very interesting, and this is not you wouldn't necessarily kind of factor this in on the kind of leaderboard when it comes to which country's ahead, but there are notable differences in public opinion on AI in China and the United States. Now, unfortunately, we don't have data on China this year for public opinion. We used data last year from Ipsos, and they had a comparison between China and the United States, but I don't think they surveyed China again this year. But Americans are very pessimistic about AI. Like I think when you look at the question, do you agree that AI products and services have more benefits than drawbacks? I think somewhere like 30 to 40% of Americans agree, whereas last year it was close to 70% of Chinese respondents that agree. And it's a lot of these kind of non-Western nations like Indonesia, Mexico, that tend to be very, very positive and optimistic about the potential of these tools. And that I think carries a lot of implications as well, because you would imagine that a society that is much more excited about the potential of these tools might be much more willing to kind of use them, utilize them, and embrace them. And I think kind of monitoring public opinion trends in this space is also going to become increasingly important in the near future.
Yeah, and to what extent can you actually measure public opinion in China?
Yes, yeah, that's a challenge. I mean, just measuring a lot of things in China from an AI perspective is challenging. It reminds me, one of the data vendors that we work with for the index, CSAT, they publish a lot of kind of work on research in the AI ecosystem. And I remember a few years ago, I had read a briefing of theirs which looked at the Chinese government's military spending in AI. And it was very thorough, very interesting. And I asked them, like, this is really cool. Like, could we maybe do an analysis like this again for the index? And they're like, it's not feasible because the way we did this analysis, we scraped a bunch of Chinese websites. And as soon as we published our report, those Chinese websites were taken down. So, it's definitely difficult and challenging to do some of that research. But given how increasingly important and salient this AI technology is, it really kind of behooves the entire world for there to be greater transparency on how different nations stack up when it comes to the AI geopolitical race.
So you mentioned that many of these foundation models have barely kind of scratched the surface around data. On the other hand, I don't know if I'm recalling this properly, but there's a section in the report about data depletion, right?
Yes, yeah.
So uh, how do you reconcile these two things?
Well, I think it's exactly that. It's like there's the question of data, right? It's as in On the one hand, these models are being trained on increasingly larger amounts of data. And there are some people like the Epoch AI team, which is a think tank that we partner with. They predict that, in a few decades, we might run out of high quality text data and high quality image data to train these systems. And I mean, there's so much to be said on this. Like, on the one hand, it does seem like, in terms of how we're currently scaling these systems, we're maybe starting to get to a level where there's going to be diminishing marginal returns to data. It's not to say that, more data can't make these systems better, but it might be the case that you're going to get less and less juice out of that data lemon, so to speak. Now, on the other hand, there's a question of synthetic data, and we talk about this in the report. What does the research say on that? And it seems that the kind of researchers that have explored this question this year really seem to suggest that if you train models on synthetic data, that is data that is created by AI systems, their performance degrades quite a bit. So, I mean, this could potentially change in the near future, but it seems like so far the research consensus is that synthetic data is not really a solution to kind of our lack of data problems. But again, this kind of touches on some of the earlier points that we had mentioned, Ben, which is, maybe there is another architecture out there that is substantially more efficient. Maybe we can find ways to do a lot more with a lot less data. Maybe you might even have new AI systems that are better at just kind of taking data that is already out there in the world and feeding it to AI. I mean, you think about a human, right? Like, a human has read nowhere near as much as GPT-4 has read in its training, but a human every single day has millions of visual inputs, millions of auditory inputs, and these all kind of feed into the human mind. And you could imagine a world where, if we could find ways to capture all of this data and give it to systems, maybe we can continue kind of scaling them and growing them. But I think that the reason we kind of included that in the index this year is this is a real question that I think the community is going to have to kind of, think about in the near future. Where are we going to go? Like, data has powered these systems and has gotten them to where they are now, but where we might need to be in 5 years or a decade, it's not necessarily clear to me if we can rely exclusively on scale as a means to get us there.
So a couple of points. One is actually, if you at least believe what Mistral is saying, right? So one
Yeah,
of their secret sauces is data and data quality. The reason they can
yeah,
train models more efficiently and more cheaply is they invest a lot of time in
yeah,
data tools. Second, so you mentioned, and I agree with this as a general principle. I think that the synthetic data is a mixed bag
yeah.
in terms of being helpful. So my question to you, Nestor, is data generated by generative AI considered synthetic data? Because I'm telling you, man, we're getting flooded with generative AI blog posts and articles that are being scraped by the same teams that are training this foundation model.
Yeah, I
So
mean, I think definitionally, yeah, you would consider it to be synthetic, and yeah, that that certainly poses a bit of a problem. Yeah, it's kind of it's funny to think about when you phrase it in that way.
yeah, yeah. I mean, I think that there is a lot of data now. I mean, I don't know this for a fact, but
Oh, I'm sure there
my
is. Yeah,
sense is,
like
yeah,
yeah, I'm
my,
I'm sure. Yeah,
yeah, yeah.
I mean, I have friends who have created startups that tell me like all their marketing material is ghost written by GPT-4 or Claude.
So there's a chapter on responsible AI, right? So
Yes.
and it's an important topic.
Yeah, new chapter this year as well, worth mentioning.
Yeah, yeah, for our listeners. So what are some of the favorite things that you can tell us about that chapter?
Yeah, I mean, there's a lot to say. I think I'll kind of focus on three. The first is that I think it's interesting to see some of the kind of challenges that have emerged when you look at LLMs emitting copyrighted material. So there's now a lot of kind of research that shows that there are several cases where, you go to like a text to image generator and you ask them for like a generation of toys, and they will basically spit out an image from Toy Story. And, this creates very interesting legal questions because a lot of these companies, in a lot of cases claim they don't train on copyrighted data, or if they do train on copyrighted data, they try to justify it under the grounds of fair use. And I still think that's very much an unsettled legal question. And I think there's already a few lawsuits that kind of speak to this kind of topic. But it's interesting to see that that is for sure a case. I think secondly is that researchers this year on the responsible AI side, they seem to be kind of uncovering a lot more complex vulnerabilities in LLMs. So in last year's chapter, we kind of showed how, when ChatGPT was first released, you could ask it to build a bomb and it would tell you no. But then if you said things like, oh, I'm doing a science project for school and I need to know how to build a bomb so I could stop a terrorist from building a bomb, it would still tell you how to build a bomb. I think research this year is showing that there is a lot less obvious ways to get LLMs to kind of exhibit harmful behavior. Like you can ask models to infinitely repeat random words, and in the process of doing that, you can extract information that is personal and sensitive. So I think the kind of adversarial challenges that these models pose have also increased. I think third, and this is probably one of, I think, the most significant takeaways of the report, is that it really seems like there is a lack of robust and standardized evaluations for LLM responsibility. And what I mean by this, we talked about benchmarks right at the beginning of the podcast, but when AI developers release models like the big dogs like OpenAI, Google, Anthropic, Meta, most of them, if not all of them, test their models against a couple of these standard general capabilities benchmarks. So I think all of them are testing, for example, on GSM-8K, which is a math benchmark. All of them are testing on human eval, which is a coding benchmark. All of them are testing on MMLU. So there's an understanding that when it comes to general capabilities, there's a few benchmarks we all need to measure our systems on. Yeah, when it comes to responsible AI, they're kind of all doing their own thing. Each of these developers does have their own tests, but they all test on different benchmarks, and it's not necessarily clear why certain developers choose one benchmark and why other developers choose another benchmark. And I think that carries with it a lot of problems because I think as these models become increasingly deployed, it's going to become increasingly important to know what their limitations are, what their risks are. And if these models are just basically being arbitrarily deployed or trained or, sorry, arbitrarily tested on different benchmarks in the responsibility domain, it's difficult to know really kind of which model is more responsible than another. And it's not clear if, these developers are just doing this because these benchmarks suit their models or if they just feel this is the best benchmark. But that's one of the interesting things that we found in this index, that there's really an inconsistency in responsible AI benchmark reporting.
So now, if you read the release notes when a new model comes out, or the blog post or the technical paper, right? So they'll tell you this is what we did for managing risk, right? So
Yeah,
we did red teaming.
yeah,
Maybe we did RLHF, right?
yeah,
Um, but as to your point, they describe this all at a high level.
yeah.
So I guess what you're saying is maybe you can have secret sauce on the architecture itself, but on the responsible AI testing, what's there to hide? You might as well share that, and then we all benefit.
Well, yeah, I mean, that's like, I
Yeah.
think unquestionably these tools, I mean, they're a part of our life now. And with anything that becomes a part of our life, it could really affect people in serious ways. And, I think these companies have a responsibility to be transparent about what the limitation and capabilities of these tools are. And I think my point isn't that these companies are not transparent. They're certainly doing these evaluations. But my point is just that these evaluations are different, right? It's like, if they were doing general capabilities evaluations and we're all testing on a different benchmark, you wouldn't really be able to say like, oh, this model is better than another model. And that seems to kind of be the level we're at in the responsible AI ecosystem. And part of the reason this came up is because we were trying to find like what's the most responsible AI model. And we kind of realized like there's really not a lot of benchmarks out there for this that are universally applicable across these models.
Or I guess in the release notes or in the technical report, they can say, all right, so for responsible AI, we did the following. We used the following benchmarks
Yeah.
for the following reasons, because we tried these other benchmarks, they're
Yes.
crap, right? So
Yeah.
then that way you learn from, okay,
Yeah.
moving forward, this is the right way to do it, right?
Yeah. Yeah. And I mean, I think that kind of also speaks to like a broader a broader point that I think the report makes is that, you know, we this report has been around for 7 years now. I think in the first few years, AI definitely seemed to be an academic topic. Like it really kind of didn't preoccupy industry the way that it does now. And now it's not only an industry topic, it's kind of an everybody topic, right? Like we all interact with AI. I think we have data in the report which shows that a substantial proportion of the world is aware of ChatGPT. Like these systems are here and we're going to start interacting with them. And these kind of questions of responsible use are going to become questions we can't really escape from, and we're going to have to find ways to answer them in the future.
Or the other thing, Nestor, is they can contribute back their learnings on the responsible AI front, right?
Yes.
So, for
Yeah.
example, if they test uh, on image generation or whatever, something on toxicity or fairness,
Yeah.
and they found that the benchmark data sets were flawed or whatever, and they fixed it, then contribute that back, right?
Yeah, exactly.
Yeah, yeah. Otherwise, people are will just waste their time, or
Right.
or end up releasing models that are not as good as yours, but maybe that's your objective anyway, right? So,
Exactly. Yeah. That's the question.
yeah, yeah. Because the other thing about these release notes is there's a lot of, I guess the politically correct term is there's a lot of CYA as well, right? So,
Yeah.
there's a lot of I mean, they say the limitations, but it almost like it's not necessarily, it's mostly so that to minimize uh I guess liability on their part, right?
Yeah, I mean, like some of these companies, I think, they do have engineers that, of course, are committed to the safe and responsible deployment of these tools. But there's also a lot of money to be made here, right? Like investors are pouring millions of dollars into these tools, if not billions, as the report suggests. And at some point, you want to be the best player or you want to be one of the best players, and you're going to have to do that with results. So there is, there is that tension there sometimes between being transparent about limitations and risks and not necessarily revealing too much about your product. But I think ultimately, if you're a person that really believes in the proliferation of responsibility, that's something that's very important and essential.
All right, so I cannot end this podcast here because it's a bit of a downer. So let me close with one last question on a more positive note. So
Yes.
you have a chapter on science and I guess healthcare,
Yeah.
so give us some positive things out of that chapter.
Yeah, I think what you're really seeing is a lot of AI really kind of being used to solve a lot of scientific problems that just required a lot of kind of computational brain power. And it really seems like these are kind of problems that AI was made to uniquely solve. But one of them that kind of comes to mind is GraphCast, which is a new high profile weather forecasting system that comes from DeepMind that delivers really accurate forecasts and substantially less lead time than other measures. There's new systems like GNOME, which are AI models that have discovered substantially more material and crystal structures than was previously known by science. And I think one that is kind of really interesting to me that really kind of illustrates in a lot of ways, the capabilities that AI has is alpha-luminescence, which was released by Google DeepMind. And this model basically predicted the pathogenicity of 71 million luminescence variants. And these luminescence mutations are these genetic alterations that could affect how human proteins functioned. And I think the key thing to kind of acknowledge here is that there are 71 million of these different variants. Before, human annotators were able to confirm 0.1% of all mutations. This model classified close to 89%. So that's just kind of an example of how AI is being used to kind of solve these brute force problems that I think took humans a very long time to solve before. And I think there's a lot of reason for excitement about a lot of those things.
And with that, thank you, Nestor. This was amazing.
Yeah, thank you for the invitation. I mean, I'll also kind of echo what you noted at the top of the podcast. The report's long, and I don't think we even talked that much about the chapter on economy, but there's a lot of really good information in the report. And I mean, as the author, I personally hope that everybody in the world reads it front to back, all 400 pages. But I think the best bet is to take a look at it, find the sections that you are most keen and interested in, and do a deep dive exploration there. And I promise for any viewer, any listener, there is something in there for them in that report.